Good afternoon, everyone. So a very nice presentation by Ashok. I really enjoyed it. Hope we continue. I am able to continue the momentum. So what I did was in my presentation, I actually removed anything related to what is IoT, why IoT, and why do we need IoT, or what are analysts saying about the numbers in IoT. Because I think the fact that we all are here, we all believe that it is happening, and we are in the middle of the whole whirlpool where the whole IoT next is happening. So I'm going to focus on IoT platform and the solutions, and it all comes from I mean, the earlier session was a lot about the networks, the protocols, the standards, but I'm going to talk about what are we building on top of it. And what does it take to build, what do we need to build this entire platform and solutions. So moving forward, and this is an IBM point of view as to how we are building it. So we launched our IoT business unit at the start of this year. So IBM has a designated business unit which is looking at Internet of Things as the use cases, as technologies, and we have it in 4 layers. Which the first layer start at devices and networks. IBM doesn't have any product here. We are not present in devices and networks, but we recognize that it is really needed for us to connect to them, and hence we follow standardized protocols, and we connect to a large range of devices and networks. So we do partnerships, and IoT is extremely ecosystem. That's what I think we all understand, that there is so much of ecosystem partnerships that you need to do to make a single thing possible as a use case. So we partner with ARM, we partner with TI, we partner with Intel, and what we do is, in fact, we also have what we call as recipes. We connect the code which is needed to connect these different OSs. We just had in our community a Tizen OS recipe being input. So there is a connection that we make, and we use MQTT as a protocol, which is actually it falls in the same space as CoAP, but yes, we use MQTT, which is an open source. IBM had invested a lot of things in MQTT, and we gave it back to the community for it to grow. And using our MQTT libraries, you can build a library and build a connection to any kind of device which is there out in the market. So that's how we connect to various devices using standardized protocols, using standardized libraries which are all available on open source. Then what do we do next? We take it to the platform. A platform is a place where you collect the data, you connect to the devices, you get all the data, and you want to analyze it. So we have built a platform, and we built it on IBM Bluemix, which is our platform as a service available that has services related to right from databases to Watson, to predictive analytics, to predictive insights, reporting. So all our services are available in Bluemix, and we have IoT specific services called Iod Foundation. I'm going to talk more in detail about those services, and all our services we are launching through Bluemix so that it makes it very easy for people to build use cases. So for example, IoT use cases, if we see, they are not pure IoT, just collect the data. They have to apply to an industry. It could be a geolocation service that you want your IoT service to marry and build an application. It could be a real-time data which you are monitoring from a machine. It could be you want to analyze and predict the failure of a machine, so you need some predictive capabilities. So all these services are available in Bluemix platform, and IoT platform is a subset of that, looking at specific IoT connect and collect, and connect the events, dashboard, and see them in real time, so that we apply and we make a larger platform also available to our clients. So that's how we have IoT platforms. We have also been present a lot in continuous engineering. So whether it is Bosch or large OEMs and automotives like BMWs, they are already big users of our lifecycle management tools which provide embedded software design. So if you want to create embedded softwares for machines and for automotive components, you need those development tools. And what we did was, when we formed our IoT BU, we brought all those products into this portfolio, because it makes sense for us that if we are targeting OEMs and if we are targeting large automotive organizations, then the engineering life cycle is managed through these tools. So they are also part of our portfolio. And then what we did was, when IBM was forming this business unit, we saw that we already have very good applications. Applications like Tririga. So Tririga does building management. It does real estate optimization, and you can actually measure energy consumption in a particular room or in a particular floor within sites of various buildings. We had Maximo, which is an asset management tool which is used heavily in oil, gas, aviation sector, where the whole asset model of, a machine is an asset, or an oil rig is an asset, or an AC is an asset. So the whole assets within a building or within an enterprise are all managed through Maximo. And what we saw as a turn in the in this last couple of years was that IoT use cases are all built on asset management. IoT use cases are built on building management, and these are being the center of all the change or the revolution which is happening in IoT. And hence we brought these products, and they form the core applications of our IoT story. So today we can do condition based maintenance. We have Airbus as a customer, which so in an Airbus, when it creates an aircraft, it has got 3,000 or between 3,000 to 6,000 parts within it, and there is a big supply chain management which they have to do, and the part fails. So what do they do? So Airbus is working with us to build a condition based maintenance solution where they can predict the behavior of a failure of a part. So you can find out if a part is failing and how is it failing and what can we do about it, how can we replace it, how can we change it. So that whole cycle is being managed because we know the assets, we know the asset model, and all we have to do is instrument device model on top of it. Right, because device model is very different. You might have multiple Raspberry Pis or Arduinos or TI devices, and I mean there are so many different kinds of devices which are there in the market, and the model of maintaining the devices is very different. So what we are trying to do is we're trying to map the device model to the asset model so that they stay close and it makes sense to the customer. And this is same as what Industry 4.0 is talking about. It's talking about cyber physical systems. So your physical systems were already maintained in inventory systems and asset management systems, whereas your cyber systems, which are like these devices and these sensors, they had no clue of how to get data out of a machine. So that the bringing of both the things together and the model together, that's what we are doing through our platform. And we have a lot of use cases and a lot of customer case studies where we are applying it and seeing the benefit which the customers are getting out of it. Now going forward, there is another thing that we are focusing on, which is the industry transformation. So what we are noticing is that there are industries which have specific needs. For example, automotive and electronics, these are the ones which we are focusing. They have specific needs, and we have launched offerings for IoT for electronics and automotive. I'll talk more in detail about them. So this is our Iod Foundation Platform, which is available on Bluemix. If you see, there are 4 quadrants. We are focusing on 4 quadrants. The first one is connect, which is get the data, connect to various kinds of devices through the mechanisms which I talked about, collect the data and get it. We have a very scalable mechanism which takes like 1 million concurrent sessions, and it is also available in real pocket size, right? You can have 5 devices, whereas you can have 500 or 5,000 or 5 million devices coming onto that platform. So it's available based on how you want to use it. The second is the analytics. This is the real-time insights, which talks about getting the data and analyzing it in real time. So IBM has invested a lot in Spark, and we use the Spark engine to get the streams of data and analyze it in real time. So there are a huge number of rule sets that you can build on, and then you send it to your backend applications. So for example, you have a backend application and a sensor is sending temperature 25 degrees centigrade for this room every 10 seconds. If you send this 10 seconds, though it's a 4 KB data, it's not more than that, but if you send it so often and if you send it for all the devices, your backend systems are going to die. And nobody wants their backend systems to die because of this new IoT data which is coming up, right? IoT data is so much huge in number, but you don't want them to flood your backend systems. So this real-time insights helps you in thresholding. It takes as a Spark stream, it thresholds, you can apply rules and say, oh, only if the temperature is above 25 degree, which happens maybe thrice in a day, then you send the data backwards. So those kind of thresholding, throttling, and that what you want to do on real-time data, you want to apply any rules which is like if then else and have multiple events talking to each other. That's what happens in real-time insights. And we are building it. So the new service is like freshly launched as I speak, and we are building a lot of capabilities of analytics, which is predictive analytics and cognitive analytics. So when I take cognitive analytics, I talk about, we just acquired weather.com. I'm not sure how many of you know that, but you would have checked weather.com. IBM acquired the entire services and platform of weather.com, except the TV channel which they have. So we have the control of all the weather data. And now we can build lot of, and weather data, by the way, is available as a service on Bluemix. If you want to use it in any of your application, please go ahead and use that. But what that gives us is a lot of context to the data. If I know the weather outside and I know what the ambient, what the temperature should be, and then I get a data from devices which say what the ambient temperature of the room is, it makes a lot of sense. So the same weather data, it applies to insurance use cases, it applies to within a car, within a home, and at several places. So that's where we are building our predictive and cognitive capabilities. The next is the risk management, and I think someone did mention about it, about the security which is important, that how do you authenticate the device, how do you ensure that there are no rogue devices, how do you see the presence of anomaly detection in terms of, at this point of time there should be no event coming from the device, but you receive an event which means that there is an anomaly. So those kind of things in terms of encrypting the data, in terms of how the entire security mechanisms should be applied to the platform, that's where we are bringing in security services. And the last is the information management, which I think is fairly clear because it kind of tells how do you store the data, how do you manage the data. And we have a choice of multiple databases. It could be MongoDB, it could be Cloudant, it could be a time series database like our Infomix time series database. So you have a choice of multiple databases which can be used, and how do you, depending on your, if you need JSON storage, then you use this data. If you are taking it for more reporting purpose and visualization purpose, then you use a certain kind of data. So all those aspects of IoT use cases needing different kind of data are catered to in information management. And as I mentioned, this is all built on Bluemix, which is built on OpenStack, and Bluemix is a Cloud Foundry based platform as a service. I talked briefly about these recipes, but I'll talk about it because I'm passionate. My team builds here, and the team which is out here in the IBM booth, they are the ones who are the creators of all these recipes. So what we do is like a dish that we prepare at home, right? You have ingredients and you have a steps and methods to put all the ingredients together to make something really tasty. So that's what the recipes are. The ingredients are defined that this is a device, it has three sensors in it, this is the OS it has, and these are the steps of connecting this device to the IBM Cloud Platform. So that's what a recipe is about, and we have several device recipes. We also have application recipes which take this data and connect to backend applications, and the good thing is it's an open source community. So you can write a recipe and upload it with your name. So it's up and running. So it's an open source community which is growing. We have a lot of interesting recipes. So if you are an entrepreneur, you can put up a recipe and ask your customers to come and visit it. It's up and running. It's up, and you use Node-RED as a Node-RED is is an open source tool. Again, it's a visualization tool, which is again open source. So you kind of, and you can develop Node.js applications. So it gives you a mechanism to get onboarded, understand, with several tutorials available for you to see how the connections to IBM Bluemix are possible, and it gives you a mechanism to create your own prototypes and own demos, which you can put up and show it to your end customers. I'll move ahead. These are a lot of device recipes examples which are there. I'll move into insights. So I'm just moving into something which is related to real-time insights, which I talked about. So this helps in monitoring finding out the behavior of the assets, that what are the assets which are critical to my business. And what we do is we instrument the devices using the recipes, and we get the data using real-time insights onto a cloud, and which helps us find out insights about the devices. It could be related to devices, or it could be related to the assets. So remember, I talked about how the asset model and the device model need to come close to each other. That's what we do there. And very easily, by using REST APIs, you can connect to any backend applications and invoke or do an alert mechanisms based on the insights which this Spark based engine does for us. So based on that, you can send it to your any backend applications, and it could be inventory applications, it could be building applications, and that helps. So you don't do away with your existing apps. A lot of customers say, oh, IoT, you are talking about new, but what do I do? And IoT is not new actually, right? I mean, we have been doing IoT, it's just that we're instrumenting them all together now. So this kind of ensures that you get the data, you get it onto a cloud, and based on the insights which are generated, you invoke your backend applications. So like again, this is just an architectural diagram on real-time insights, where we have a pump which is giving SCADA-based SCADA data, and there is a gateway which is catching the data from all the devices, or all the assets in the shop floor, and it sends it to Iod Foundation, which is the collect and connect service, and then that sends it to real-time insights, which does a real-time analysis of and because it's based on Spark, so it can divide data into multiple and do a parallel processing for the data, and then give meaningful insight and recommendation to a backend application like Maximo. So this whole thing is built in, and we give it as a service. All you have to do is go to Bluemix and start using this service. This is one example where we have done this with Silverhook power boats, which is basically they have racing boats. So the racing boats has got very good telemetry. So you can replace it with a car. It's a similar kind of a car system. It has got a telemetry system within it, and it has to tell in real time to the racers that how many people are close to them, or do they need to take any diversions, or somebody is going to crash into them. So the speed of the motorboat and the GPS locations and the whole map and everything is sent in real time to the backend. There are a lot of doubts people have as to how cloud helps. Do we do edge or do we do cloud? But this is an example where we actually have racing boats sending it back to the cloud, and insights from the cloud being given back to the driver while he's racing at a very high speed. The interesting thing is the application is Python based. So in Bluemix you can write app on Node.js or Python or Ruby on Rails. So I mean on Java. So there are various mechanisms in which it gives you a very open environment for you to write apps, and that's the beauty, that you can make it and make it very developer friendly. And I think that's an important challenge in IoT. I'm not sure how many, there are so many challenges in IoT people talk about, but personally from my experience, what I have seen in IoT is, on one hand, there are half of the people who are saying, oh, IoT is really complex, it's factory, it's machines, I want the data, I know the appliances. And on the other hand, there are huge bunch of developers who says, oh, we can make it really easy. And making a use case possible through these people who find it really easy and people who find it really difficult, and and getting the data and ensuring that the data comes this side and they are able to make an app which is really easy for people to consume. I think that's a very big implementation challenge for IoT, which we should try to solve, but a lot of customers struggle in that, because they know what their data is, what the systems are. They've been having data, but they never knew what to do with it. And to make it really user friendly and make it really adoptable, which can be adopted widely within the whole spectrum of customers, I think that is a very big challenge. And somehow I feel that in these kind of use cases, if to a developer you tell him you have to make a Python IoT app, it's much easy. But if you give him huge set of PLC controls and tell him to play with the PLC control APIs, I don't think a developer would be able to do that. So actually the marrying of the cyber and physical is a big challenge in IoT, which should evolve with as technologies improve. IoT for electronics, I'll spend some time in this. So we have evolved an offering called IoT for electronics. This focuses on, so it's an offering which we have created which uses IoT platform. But in electronics, what we have seen is when we are engaged with a lot of customers, that there are unique challenges. And when we say electronics, we are talking about OEMs who are creating the electronic products. So what is an electronic product? It could be a washing machine, it could be a microwave oven, it could be a refrigerator, it could be the AC, it could be we don't consider car here because we have a separate offering for IoT for automotive, and we understand the use cases are a little different. But anything which has got electronic componentry, it could be an elevator. These are all considered electronics for us. And there is a lot of need of, for example, I want 75,000 washing machines to be provisioned in one manner, or I want change to be done or firmware update to be done to 100,000 microwave ovens for all my customers. So the electronic majors are struggling that how do they manage these end consumer devices which are there in the consumers, and they want to provision them, they want to do firmware updates, device management, they want to obtain the data, do a little bit of analytics and see which, where from customer service or warranty perspective, what might fail. So we have provisioned our offering, and we have created IoT for electronics, which has asset management included in it. It has device networks, connections, the life cycle management of that machine, of that microwave oven. How do you manage the life cycle of it? So all these things are built into it. You have to maintain that. A lot of electronic majors, they have AMCs, right, and they want to maintain maintain that machine over a period of time, and they actually get paid on the maintenance contract that they have with the customers. So they want to maintain those, and all this is requires special IoT apps and solutions, and that's why we created this offering. It's again based on our platform as a service. It caters to real-time analytics, predictive, and cognitive, which I mentioned about. There is a lot of value-added data. So the use cases come up if you have value-added data like weather, or or crowd, or the data which is contextual in nature. So we feel that IoT will start having value when you have a lot of contextual data coming into it, and because data just from pure machines is boring. There's not much you can do with it. Our next is IBM Iot for Automotive, and we have a specific offering here, and this is because we felt that we are going into the connected cars, and we did a lot of work with OEM majors, and we felt that driver behavior analysis in terms of map routes, and in terms of how do you do map analysis which you can give back to the driver. So these are unique use cases for automotive, and which means that data is real time. This is my last chart. So there is a lot of analytics that needs to be done in real time, and it needs special handling. So we had a lot of assets from our research labs which we kind of brought in, and have created this offerings which we are giving it to a lot of our OEM automotive customers. So that's all. I'm at the last chart and I'm done. I don't have anything else.